Ever try to picture, like, the energy bill for ChatGPT, training those massive AI models? It's got to take a crazy amount of power, right?
Right, yeah.
And we all know processing mountains of data, that's energy intensive. But how we store it all, that's a hidden energy hog, turns out.
It's interesting how we focus so much on the processing itself, but the infrastructure around it, like the data storage, that has a way bigger impact than people realize, I think.
Totally. And that is exactly what we are diving into today.
Okay.
We've got some super interesting stuff from a Tech Field Day video featuring Solidigm. They're all about data storage. And they break down some pretty shocking research on the hidden energy costs within AI.
Okay.
So our big question, how do we make AI more energy efficient, without killing the performance that makes it so powerful?
Yeah, that's the million-dollar question, right? Especially with AI growing as fast as it is.
For sure.
We're seeing these models get more powerful all the time, but that progress, it comes with a pretty hefty energy bill.
Oh, yeah.
Even the big names in tech are feeling it.
Oh, absolutely. Yeah. I mean, Sam Altman, OpenAI CEO, flat out said there's a lot hard in AI, but energy is the hardest.
Yeah, and even Mark Zuckerberg admitted that, Meta would be building even bigger AI clusters if they could just get the energy to run them.
Wow.
Clearly, energy consumption is a huge roadblock
Totally.
for AI development.
Yeah, and this is not just them talking.
Yeah.
Meta and Microsoft Azure actually did some research
Right.
showing that data storage drives, they're eating up a huge chunk of the total energy used for AI.
Wow.
We're talking 35% for Meta's AI recommendation engine. The one telling you to buy those shoes you definitely don't need.
Right.
And a whopping 33% from Microsoft Azure's cloud services.
Wow, that's a lot.
That's a massive amount of their energy budget just going to keeping data accessible, right?
Yeah, and here's the thing. This is all happening while the amount of data we're feeding these AI systems, it's exploding, right? We've moved beyond just text. It's all about this multimodality now, text, audio, video.
Oh, for sure, yeah. Like a page of text is nothing compared to, say, a minute-long high-res video that's on your feed.
Right. All those pixels.
All those pixels add up.
It's a huge difference in data density.
Huge.
Like a page of text, that might be a few kilobytes, but a minute of high-res video that can easily be hundreds of megabytes, even gigabytes, depending on the compression.
Oh, wow.
And that's just 1 minute.
Yeah.
Imagine AI analyzing hours of footage.
It makes you wonder what those viral TikTok videos are doing to these data centers.
Seriously.
To the energy bill.
Yeah, it's a perfect storm, right? More complex models, we've got denser data, skyrocketing storage needs.
Yeah.
It all equals this massive jump in energy demand.
Makes sense.
And Solidigm actually put some numbers to this, showing just how much storage different AI applications need per rack in a data center.
Okay.
And these numbers are pretty mind-blowing.
Yeah, so like how much are we talking here? Give us a sense of scale.
So a large language model, like what powers those AI chatbots everyone and their mother is using these days? They can easily gobble up 1.3 petabytes of storage.
Okay, now I don't even know what that means. Put that in perspective.
So 1 petabyte is 1 million gigabytes.
Oh my gosh.
That's a lot of data.
That's insane. And I'm guessing that's on the low end.
Oh yeah, absolutely.
Okay.
A large video model. Now we're talking 16 petabytes.
Wow.
Oracle's reference architecture, a whopping 32 petabytes.
What?
These models need access to massive amounts of data to function, and as they get more complex, those storage needs, they're only going to increase.
Right.
So the question becomes, how do we handle this growing demand for data storage in a way that's, sustainable and energy efficient?
Right.
That's where Solidigm thinks they might have a solution, and it all comes down to the type of storage we're using.
Okay.
They're big proponents of something called QLC storage.
Okay, so we're getting into the nitty-gritty here.
Yeah.
For those of us who are not storage experts,
Right.
what exactly is QLC storage?
Yeah.
And what makes it different?
So most data centers right now, they're using TLC storage.
Mm-hmm.
You can kind of think of it like squeezing 3 people onto a bus seat.
Okay, yeah.
It works,
Right.
but it's getting crowded, right? QLC is like figuring out how to fit 4 people in that same space.
Right.
More data, same space.
Right.
You're probably thinking, doesn't that make it slower?
That's exactly what I was thinking. Doesn't that defeat the purpose if it uses more energy in the long run?
That's the trade-off with QLC. it can be a bit slower than TLC, which is a concern when speed is everything, right, for AI processing.
Yeah.
But Solidigm is addressing that, and that's what makes their approach so interesting.
Okay.
They're focusing on optimizing the duty cycle of their QLC drives.
Okay, now we're getting into the jargon.
Yeah.
What is a duty cycle in this context?
Okay, think of it like a car engine. It's not always running at max power, right?
Right.
Same with these drives.
Okay.
Solidigm optimizes how often the drives are actually working, reading and writing data to minimize energy wasted just idling.
Okay, so like minimizing the wasted energy.
Exactly. And then for those moments when you DO need peak performance,
Yeah.
they use a smaller amount of TLC as a cache.
Oh, interesting.
So the most frequently accessed data that's ready to go on the faster TLC, while the bulk of it sits on the more energy-efficient QLC.
Gotcha. So it's like a hybrid approach.
Exactly.
Getting the best of both worlds. That's clever. But does this actually work in the real world? Or is it just theoretical?
Well, they've got real-world results, too.
Okay.
Solidigm highlights this case study with a data analytics company called Ocean.
Okay.
They switched over to Solidigm's QLC drives and saw some pretty incredible improvements.
Okay, hit me with the numbers.
They slashed their rack space by 2/3, cut their power consumption by 6.5 times,
Wow.
and reduced their annual energy spending by a factor 4.
Wow, those are some seriously impressive results.
Yeah.
It really drives home the point that smarter storage can make a huge difference in AI energy efficiency. You know, this whole conversation has me thinking, we've been talking a lot about hardware,
Right.
but what about the software side of things? Could we be, like, smarter about how we use data in the first place to reduce the need for so much storage?
That's a fantastic question.
Right.
And it gets to the heart of a bigger issue in AI development.
Yeah.
Do we always need more data?
Right.
Or can we get the same performance, even better performance, with less data by developing, leaner, more efficient algorithms?
Right. It's like that old saying, work smarter, not harder.
Exactly.
Maybe we can apply that to AI.
Absolutely. And there's a lot of cool research going on in that area.
Yeah.
Scientists are looking at techniques like data compression, feature selection, even designing new types of neural networks that are just inherently more data efficient.
So instead of just throwing more data at the problem because it's being more strategic about how we use what we have.
Exactly. And this ties into another crucial thing about AI and data storage.
Okay.
Data quality.
Right.
Just because we can store tons of data doesn't mean it's all good data.
Right.
It's like that junk drawer in your kitchen.
Oh, tell me about it.
Packed full of stuff.
Yeah.
You only ever use about 10% of it.
My junk drawer is a black hole.
Right.
Yeah.
And just like that junk drawer, having irrelevant data, it can actually be bad. It can slow down processing, make the model more complex, and even increase that energy consumption.
Wow, okay.
So there's a real opportunity to be more strategic about what we collect, how we store it, and how we use it.
So it sounds like we're talking about a pretty fundamental shift in thinking when it comes to data in the age of AI.
Totally.
It's not just about more storage, it's about smarter storage.
Right.
Smarter use of data overall.
Absolutely. By focusing on that data quality, using those data-efficient algorithms, and embracing technologies like QLC, we can create a more sustainable and energy-efficient future for AI.
And speaking of the future of AI, one thing that caught my eye in the Solidigm stuff was this idea of synthetic data. They said it could even be bigger than real data by 2030.
Wow.
What is synthetic data? And what's its role in all of this?
It's a really fascinating concept.
Yeah.
Synthetic data is basically artificially generated information that's designed to mimic real data without actually containing any real personal or sensitive information.
So instead of using like real customer data to train an AI model, you could use synthetic data that looks and acts like the real thing, but doesn't actually belong to any real people.
Exactly. It has huge implications for privacy and security, especially in fields like healthcare and finance, where data is super sensitive.
That makes sense, but how does this tie back to energy consumption?
Well, if you're using real-world data, you need to constantly collect more of it to keep your models updated and running smoothly. But with synthetic data, you can potentially just create as much as you need whenever you need it.
Oh, interesting.
No more waiting around for new data to be generated.
So you could potentially reduce the need to constantly collect, store, process new real-world data.
Exactly.
Which saves energy.
Exactly. It's not a perfect solution.
Right.
Generating good synthetic data, it's hard.
Yeah.
And it might not be right for every situation,
Right.
but it's a promising area of research
For sure.
that could have a big impact on the energy footprint of AI.
It's like we're on the verge of this whole new frontier in AI.
Yeah.
And energy efficiency is front and center.
We are. And like any new frontier, there will
Yeah.
be challenges, right?
Right.
But by being mindful of that energy consumption, exploring these new technologies,
Yeah.
and asking the right questions,
Yeah.
we can make sure that AI has a bright future,
I love that.
both literally and figuratively.
A bright future for AI. Speaking of asking the right questions.
Yeah.
There's one more point from Solidigm's research I thought was interesting.
Okay.
This whole idea of data repatriation.
Yes.
Have you heard of this?
Yeah, it's a big trend, driven by a few things. Growing concerns about data privacy,
Oh.
evolving regulations,
Mhm.
and even geopolitics, believe it or not.
Okay, so break it down for me. What exactly is data repatriation?
Essentially, it's companies bringing data that was stored somewhere else, often in other countries or with cloud providers,
Right.
back under their own control. Usually that means back to their own data centers.
So it's like bringing your data back home.
Exactly.
Okay.
And there are a few reasons for this.
Yes.
One is the rise of all these data privacy regulations like GDPR in Europe.
Right.
Similar laws are popping up everywhere.
Gotcha.
These regulations often have strict rules about how companies can collect, store, and use personal data. And a lot of organizations are realizing it's easier and safer to just manage that data themselves.
So part of it is about making sure they comply with these increasingly complex regulations?
Exactly, but it's not just about compliance. There are also growing concerns about data security.
Right, with all the data breaches and cyber attacks these days.
Exactly, and repatriating their data gives companies more control over its security.
Right.
Potentially reduces the risk of unauthorized access or breaches.
So it's about peace of mind, knowing that their data is safe and sound under their own watchful eye?
Exactly, but how do you think this data repatriation trend ties back to AI and energy consumption?
Well, my first thought is that it seems like it would increase energy consumption.
Interesting.
Because if companies were bringing all this data back to their own data centers,
Yeah.
they might need to build or expand those facilities,
Yeah.
which requires energy.
That's a really good point.
It seems a bit counterintuitive.
It does, but here's where it gets interesting. While data repatriation might change where the energy is consumed, it also gives companies more control so they can actually be more strategic and potentially more efficient with their energy use.
Okay, I'm intrigued. How so?
For one thing, bringing that data back in-house lets companies use more energy-efficient technologies and practices in their data centers. They have more say over things like cooling systems, power management,
Right.
and even just choosing the most efficient hardware, like we talked about earlier with Solidigm's QLC storage.
Right, so while they might need more data centers overall, those data centers can be designed and operated with energy efficiency in mind, like from the ground up.
Precisely. And this all links to a larger trend of companies becoming much more aware of their environmental impact
Yeah.
and looking for ways to reduce their carbon footprint.
Right, it's not just about the bottom line anymore.
Right, and data repatriation, when it's done right, can be a part of that.
That's a really fascinating perspective.
Yeah.
So data repatriation, while seemingly counterintuitive, could actually be a net positive for energy efficiency in the long run.
It certainly has that potential,
Okay.
but it depends on how it's done, right?
Mhm.
If companies just bring data back without even thinking about energy efficiency in their data center design and operations,
Yeah.
it could have the opposite effect.
Right, so it's not just about where the data is, but how it's managed. What technologies are being used to store it efficiently?
It all comes back to making smart choices and really understanding the energy implications of those choices.
It's like this whole world of AI and data storage. It's like this massive puzzle, and we're just starting to see how all the pieces fit together, you know?
Yeah, for sure. And I think the coolest part is that we're really just at the beginning of all this.
Right.
Like new technologies, new ways of thinking about it are popping up all the time. And it's up to us to figure out how to use all this stuff responsibly,
Right.
sustainably.
Like we're at this turning point, right? Where energy is forcing us to get creative,
Yeah,
not just throw bigger hard drives at the problem.
totally. Yeah, it's about rethinking the whole thing, how we
Yeah.
use data, how we store it, how we can do more with less.
And as we kind of get more efficient with data, are there other benefits we might see beyond just energy savings?
Oh, absolutely. For one, you've got potential cost savings, right?
Right.
Using less energy means lower operating costs
Oh,
for all those data centers. And that could, have ripple effects in all sorts of ways.
Yeah.
Plus, the better we get at using data efficiently,
Right.
it could open up AI for use in areas with limited resources.
That's a really good point. We often think of AI in the context of these huge data centers, but if we can make it more efficient, maybe it could be accessible to way more people.
Exactly. It could democratize access in a way that we really haven't seen before.
Right.
And when that happens, who knows what incredible stuff we'll see.
So exciting.
It really is a super exciting time to be thinking about the future of AI. And I think energy-efficient data storage is going to be a huge part of making that future happen.
Totally agree. Well, I think we've covered a ton of ground today.
Yeah, we really have.
Any final thoughts for our listeners before we wrap things up?
If there's one thing I want people to take away from all this, it's that making AI energy efficient is a journey, not a destination. There's always going to be new discoveries, new challenges, new possibilities, so we've got to stay curious and keep pushing the boundaries of what's possible.
I love that great note to end on. So to everyone listening, keep learning, keep asking questions, and we'll catch you next time.